Algebra 2B, section 6.1 through 6.3 test review. Let's do it. So, first problem says, simplify each expression. Now, remember, the square root of 49 is actually plus or minus 7. But you're not going to get it marked wrong if you write that, but all they want is what's called the principal root, which means just give the positive one. All right, what about number 2? Well, can you take the square root of a negative number? No. So this would be no solution. Now number 3, a little different. We got a negative outside the square root, so we can ignore that. We can just think of this as the square root of 1 all over the square root of 16 with a negative in front. Square root of 1 is 1, square root of 16 is 4, so this would just give us negative 1/4. All right, now you got to pay attention to the index. The index is 3. So this is asking us if we were to have a cube and the volume is 64, what would one of these lengths or sides be? Remember, volume is length times width times height. So we would say, all right, what number times itself 3 times is 64? Have to be 4. So if I put 4 here, and I put 4 here, and I put 4 here, 4 times 4 times 4 is 64. All right, here comes one of those decimal problems. So if you want to do it the way I taught it in class, you take a look at what the index is. It's a 2. You count the number of decimal places. So the number of decimal places all over the index. That's kind of the formula. And that'd be 2 over 2, which is 1. Now, what does this number tell us? It tells us how many decimal places are going to be in our answer. And then you just take everything off except the actual whole number, and you think, all right, what's the square root of 4? And that'd be 2, so my answer is 0.2. Yes, there's different ways to do it, but that seems to be like a pretty successful approach. This one, I taught you to take the radicand, slide it over, make a fraction, take the power of the radicand, put it in the top, take the index, put it in the bottom, and reduce. So that'd be a squared. Okay, next problem. First thing is, we need to look at this and say, aha, that's an odd number. And if my index is odd, that makes that negative totally okay. We don't have to worry about it. Because a negative times a negative times a negative times a negative times a negative is a negative. So this is fine. There's 5 of them here. And so if I take the 5th root of a negative, I know my answer is going to be negative. Then I take the power. Well, I take my radicand. I'm ignoring the negative right now. I take the radicand. I create that fraction. That's a 5. And I put it over the index, and that'd be x to the first. So it's just negative x. Same thing here. Take the radicand, slide it over, build a fraction, take the power, put it in the top, take the index, put it in the bottom, and that's just 10 to the first, which is just 10. And then we have to think, okay, this is a cubic root of a negative. What's a negative times a negative times a negative? Well, that's definitely a negative. So what's that telling me? It's telling me that this is not no solution. It's telling me that this is totally okay. So what number times itself 3 times will give me negative 27? Well, that would be negative 3. Negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. So what's the cubic root of a negative 27? Negative 3. All right, now they get a little bit trickier. So remember, this does not equal the square root of a negative x squared. These are not the same. See, if it was like this would be the square root of x squared, and then that would be totally fine, because then I'd put the 2 over the 2, and I'd get x to the first. But this right here is the same thing as that, which means this is definitely the square root of a negative. and that tells me that there is no solution. Same thing here that we've been doing. You take the radicand, you take the power of the radicand, you put that in the top. Whoops, that's supposed to be a 4. Put the index in the denominator, and you reduce it. What's 4 divided by 4? It's 1, which is just 5. Okay, now numbers 12, 13, 14, 15, I want you to really pay attention to the difference. These problems said simplify. That's why we only wanted the principal root. The big difference is this says find the real roots. Heavy emphasis on that little letter S. Let's go back to English class. Plural. That means there's going to be more than one answer. And it also says find the real roots. So we'll talk about that in a minute. But how are you going to do this? You're going to add 5, add 5. You're going to get x squared equals 5. And what I taught you in class was bada boom, bada bing, do the right thing. So I get plus or minus the square root of 5 because the square root of 5 can't be broken down. It's just stuck. So this one I subtract 4, y squared equals negative 4. And you can use a little common sense. Can I square something and get a negative? No. But if you don't pick up on that, you just go bada boom, bada bing, do the right thing. You should realize, aha, I can't take the square root of a negative. So this is no solution. Go on to number 14. Add 121 to both sides. So these would cancel. I'd get b squared equals 121. Bada boom, bada bing, do the right thing. So what's the square root of 121? It's 11, but it's plus or minus 11. That's why I taught you guys that little poem. A lot of you guys might go here, and if you just use your head instead of what I taught you, you might go b is 11, and that's all. And that's not the total story. Remember, it says roots. Find them all. So this is the correct answer right here. Okay, so this one, you can just add 24 to both sides to get started. So 6x squared equals 24. Divide by 6, divide by 6. X squared is 4. And here we go. Bada boom, bada bing, do the right thing. So you get plus or minus 2. Let me go ahead and turn the page. All right, number 8, simplify. Well, the first thing we need to look at is, what are we going to do here? Well, we got a couple of problems. We got the square root of 3/8, which is the same thing as the square root of 3 over the square root of 8. Now, some students might break this down right now, but some students might just multiply by the square root of 8. I'm going to go ahead and just multiply by the square root of 8, and I'm going to get the square root of 24 all over. When you square a square root, what happens? The roof flies off, so that's just an 8. Now, the square root of 24 is the square root of 4 and the square root of 6. So this would break down into 2 square root of 6 all over 8. One theme I hit pretty hard is check your oil. That would reduce to 1 square root of 6 all over 4, which you could just write as the square root of 6 over 4. You don't need that 1, but if you want to put it in there, that's fine. All right, square root of 363. I know this is a big one, but it's the square root of 121. That's a perfect square root times 3. Now, what is the square root of 121? That's 11. So there's my answer, 11 square root of 3. All right, can I take this 6 and divide it by the 3? No way. This is my oil. This is my water. Oil and water do not mix. So I just got to get rid of that radical, get it out of the basement. Now in the basement, the square root of 3 times the square root of 3 is the square root of 9, which is just 3. And this would be 6 square root of 3. Once again, you got to check your oil. 6 divided by 3 is 2. So that would be my final answer. All right, now number 19, don't you dare multiply the bottom and the top by the square root of 49 just to get the radical out of the basement. Think about this. Isn't this just the square root of 50 all over the square root of 49? And if you just think for a second, that's a perfect square root, so it takes care of itself. Also, the square root of 50 should break down to the square root of 25 and the square root of 2. The square root of 25 is just 5. And if I just bring that all back together, I get 5 square root of 2 all over 7. All right, now student number 1 comes along and they decide they're going to multiply this together and they get the square root of a big number. And that's not wrong. But what I taught was typically students get in trouble when they go big. So the square root of 35, that breaks down to the square root of 7 and the square root of 5. Now some of you are like, well, those aren't perfect square roots. And that's not my concern on this type of problem. Square root of 21 is square root of 7 times the square root of 3. Now notice we got a square root of 7 and the square root of 7. We found a match. And if we multiply those two together, the roofs fly off, so it's 7. And then we go 5 times 3 and we get the square root of 15. It's the same thing you would have gotten if you'd have gone this way, but it would have taken you a lot longer. All right. Now, example 21. A couple ways you could do this. But what I'm going to show you is this. I know that 4 times 16 is 64. My mind just went there, and I thought, aha, this is a perfect cubic root. So my answer is 4. Now, if you didn't notice that right away, maybe you would want to go kind of like this and look for 3 of a kind. Remember, these are square roots, so we were looking for 2 of a kind. This one, watch this. I'm going to take this cubic root of 4 and I'm going to make it a 2 and a 2. I'm going to make this 16 2 times 8. Notice I have 3 of a kind. What happens when you cube a cubic root? The roofs fly off. What is the cubic root of 8? 2. 2 times 2 is 4. Either way you go, you're going to get 4. Okay? Both very good strategies. Number 22. Do exactly what it says. Square it. So it's 3 square root of 5 times 3 square root of 5. Well, here's a little bit of oil. Here's a little bit of oil. Here's some water. Here's some water. 3 times 3 is 9. Square root of 5 times the square root of 5 is 5, because the roofs fly off. 9 times 5 is 45. All right, now example 23 is going to push you a little bit. Some of you didn't like it when I showed you this in class. Hopefully you're picking up on it. But I noticed that I have a 4 here, which is a nice number for these problems because I can rewrite this as 2 times 2. Why would I want to do that? Because remember, if my index is a 3, then I need 3 of a kind before the radical disappears in the basement. So by doing this, all I need to do is add 1. If I add 1 down there, I got to add 1 up there. What happens to the cubic roots? Roofs fly off. What happens up here? Well, here's my oil and here's my water, so they don't mix. But I'd get AB cubic root of 2. So I'm going to rewrite that down here. AB cubic root of 2 all over 2. And there would be my final answer. All right, now 24 is reminding me of something we talked about in class, and that is always open up your Christmas presents. This is a Christmas present. Now maybe it's not natural for you to see it yet, but that just flat out equals 4. So I get 4 over the cubic root of x squared. And yes, this was challenging when I first introduced it to you, but remember I said bottom bigger, bottom bigger, bottom bigger. In other words, what's the first number bigger than 2 that my index will go into? And the answer is 3. That means I need to add 1 to the bottom, but that means I'd have to add 1 to the top. Now what does this all turn into? That turns into the cubic root of x cubed. Remember, this is in my denominator, which is just x, because 3 divided by 3 is 1. So this turns into, look at what's in the top, 4 times the cubic root of x all over x. Done. All right, getting there, guys. We better stop right here. Looks like I'm running out of time, so I'll see you on part 2.